Hello, and welcome to Module 8.6a, Operations with Radical Expressions. Our objective for today is that we are going to, I can add and subtract radical expressions. So example 1, adding and subtracting expressions with like radicands. To add or subtract radical expressions, the radicand must be alike in the same way that monomial terms must be alike to add or subtract. So if you remember back, if we had like 8x plus 5x, we could add those together and it would be 13x. Well, we're going to be able to do the same thing with radicals. We're saying that we have 7 root 2's and we're subtracting 8 root 2's from that. 7 minus 8 is negative 1 square root of 2. Right, so we're just going to subtract and add the monomial terms that are in front, the coefficients that are in front, and we are going to be able to simplify the radicals that way. So letter B, we have the square root of 5 square roots of 5 plus 2 square roots of 5. How many total square roots of 5 do we have? 5 plus 2 is 7 square root of 5. Letter D, we have 3 square roots of 7 plus 11 square roots of 7. That gives us 14 square roots of 7. Now, take 30 seconds, complete letters D, E, and F on your own, and then check your work against mine. Letter D, we have 9 root 10's, and we're subtracting 5 root 10's from that. 9 minus 5 is 4 square root of 10. Letter E, 5 root 6 minus 3 root 6. Subtract our coefficients, 2 root 6. And lastly, letter F, we have 10 root 11 minus 3 root 11. 10 minus 3 is 7 square root of 11. Now, example 2 is adding and subtracting when we have unlike radicands. So here, what we need to do first is we need to get them to have the same radicand. So that means we need to simplify one of them. So we have, or maybe both. So we have square root of 28. Well, 28 is made up of 4 and 7, and 4 is 2 and 2. So if we rewrite this, nothing happened with the 4 root 7. It was already a prime factor to begin with. So we have a common factor of a 2 that I can bring out, times the 2 that was already on the outside, times the square root of 7, which was left inside. So we have 4 root 7 plus 4 root 7, and that's going to give us a total of 8 root 7's. All right, letter B. We have 5 root 32 minus 4 root 18. So we need to break this apart into our factors. 32, well, 32 is 16 times 2, and 16 is a perfect square of 4. 18 is going to be 9 and 2, and 9 is a perfect square of 3 and 3. So we're going to bring a 4 out in this term. So we have 5 times 4, square root of 2 is remaining. On the second term, we had the 4 originally, and we bring out a 3, and we still have square root of 2. So when we do 5 times 4, we get 20 square root 2 minus 12 square root 2, which gives us a total of 8 square root 2. Letter C. We have 7 root 6 minus 2 root 54. Well, let's break that down. My factors of 54 are 6 and 9 is 3 and 3. So 7 root 6, nothing changes. We have a 2, we've got a group of 3's that we bring out, and it's times the square root of 6. And we need to do our multiplication. So 7 root 6 minus 6 root 6. 7 minus 6 is 1, so we just have the square root of 6 remaining. All right. Now let's try a longer one. Letter D. We've got a longer set of terms that we can go ahead and work with. So 13 square root of 5. Nothing to be done there. 2 square root of 20. Well, 20 is 4 times 5. 4 is 2 and 2. 45 is 9 and 5, and 9 breaks down to 3 and 3, and 25 is 5 and 5. Okay, so now what do we do with this? Let's bring all of our pieces together. So we got 13 root 5 plus 2 times, what do we bring out in the first term? We brought out a 2, and we're left with square root of 5. Minus 5 times, we bring out a 3, and we're still left with square root of 5, and that's plus 4 times square root of 25 is 5. Our next step, we need to simplify all of this multiplication that we have. So we have 13 root 5 plus 4 root 5 minus 15 root 5 plus 20. So 13 plus 4 is 17, minus 15 is 2 root 5 plus 20. Can we combine the root 5 and the 20? No, because they don't have the same radical factors. All right. Next up is letter E. So we've got negative 11 root 50 plus 2 root 32. 50 breaks down into 25 and 2, and 25 is 5 and 5. 32 breaks down into 16 and 2, which is 4 and 4. So we have negative 11 times, we bring out a 5, and we're left with the square root of 2. Plus 2, we bring out a 4, and we're left with a square root of 2. Do our multiplication. We've got negative 55 square root of 2 plus 12 square root of 2, not 12, 8 square root of 2. So negative 55 plus 8 is going to give us negative 47 square root 2. All right, you guys are going to flip over and you're going to do the backside on your own, letters F, G, and H, and then check your work against mine. All right, letter F. We need to get them to be common radicals. So 63 is going to break down to 9 and 7, and 9 is 3 and 3. So we can simplify that. We're going to have a 3 root 7 minus 4 times 3 root 7. 4 times 3 is 12. So we have 3 root 7 minus 12 root 7. And then 3 minus 12 is negative 9 square root of 7. Letter G. 8 is broken up into common factors of 4 and 2, 4 times 2, and 4 breaks up to 2 and 2. So our first term stays the same, 3 root 2 plus 6 times 2 root 2. 6 times 2 is 12. And when you combine those together, you get 15 square root 2. Letter H. 75, we've got a 3 and we've got a 25. And 25 breaks up into 5 and 5. 48 is 16 times 3, which breaks up into 4 and 4. So we have a 3 times 5 square root 3 minus 6 times 4 square root 3. 3 times 5 is 15 root 3 minus 6 times 4 is 24 root 3. 15 minus 24 is negative 9 root 3. All right, so now we're going to do some examples of applying this. Katie is decorating a rectangular pavilion for a party and wants to bring string lights that are going to go along the edge of the roof. 2 of the sides have a length of 13 root 5 feet, and the other 2 sides have a length of 6 root 45 feet. How many feet of lights will Kate need to decorate in order to decorate the entire pavilion? So we have 13 root 5 plus 13 root 5 plus 6 root 45 plus 6 root 45. All right. Well, let's simplify these, shall we? The root 45s, that's going to give us a 9 and 5. And we can simplify that. So we've got 13 root 5 plus 13 root 5 plus 6 times 3 when we take the square root of 9 root 5 plus 6 times 3 root 5. So you have 13 root 5 plus 13 root 5 plus 18 root 5 plus 18 root 5. When you add those coefficients together, 13 plus 13 plus 18 plus 18, you're going to get 62 square root 5 feet of lights. So you'll need 62 times the square root of 5 feet of lights. All right. A business is adding wheelchair ramps to their building. The 3 ramps will require 10 root 28 cubic feet, 13 root 7 cubic feet, and 4 root 112 cubic feet of concrete. How much concrete will be needed to build all 3 of the ramps? All right, so let's start off with adding this up. So let's find our common factors, right? So we've got 10 root 28 plus 13 root 7 plus 4 root 112. So 28 breaks up into 4 and 7. 4 is a perfect square. 7 is already prime. 112 would be, well, that's 2 and 56. And then 56 is 8 and 7, which is 2 and 4. Well, I've got the perfect square of 4 there, so I'm going to write it off to the side here. So we have 10 times 2 square root 7. That's my first term. Plus 13 root 7, my second term. Plus, well, I have 1 pair of 2's right there. I'll have a pair of 2's right there. So we have 2 times, we start with the 4, and then we bring out 1 pair of 2's, a second pair of 2's, and we have the square root of 7. So now we need to multiply each of these things together. So 10 times 2 is 20 square root 7 plus 13 square root 7 plus 16 square root 7. And when you add that all together, you get 49 square root 7 cubic feet of concrete that are needed to build those 3 wheelchair ramps. All right, last one is a you try. I want you to do it on your own and then check your work against mine. Rashid is painting his bedroom. If the total area of the walls is 180 times the square root of 6 square feet, and there are 2 windows with areas of square root of 96 feet and square root 24 feet, and a door with an area of 7 root 6 square feet, what is the area of the surface that Rashid needs to paint? All right, so if we go ahead and figure this out, the total area is 180 root 6 square feet. So that is going to be what we're starting with. And then we are going to be subtracting the areas of the 2 windows, right? Because you don't want to paint over your windows. That kind of makes them not work so well. So we're going to subtract square root of 96, subtract square root of 24, and then we also need to subtract the area of the door. Again, we're not painting the door, so we're just focusing on the walls. We need to subtract another 7 root 6 feet squared. So let's break these down into common factors. I know my 6's, square root of 6, 2 times 3. There's no common factor there that I can pull out. However, 96, I don't know 96. But if I were to do some calculating on this and some logic, if my first term is root 6 and my third term is root 6, I'm going to take a guess that these middle 2 terms are going to have 6 as a factor of them. So I'm going to use some deductive reasoning. 96 divided by 6, when I type that in, I find out it's 16, which breaks down to 4 and 4. And then 24 is 4 times 6, which is 2 and 2. So now we have 180 root 6 minus 4 root 6 minus 2 root 6 minus 7 root 6. And when I do that, 180 minus 4 minus 2 minus 7, I get 167 root 6 square feet. So 167 times the square root of 6 square feet of paint is going to be needed to apply for this bedroom for Rashid. That's the end of our notes for today. If you have any questions, please bring them to class tomorrow. Otherwise, have a great day.